Approximating Distributions, Graphs. The following graph represents this binomial distribution, and because these two conditions are met, we can use a Poisson approximation to this binomial distribution. So let's have a look at this Poisson distribution on the same graph. So here's the Poisson distribution. And as you can see, these Poisson probabilities follow the binomial probabilities very closely. And this is true because these two conditions have been met. In this example, I've modified the value of p. So n is still large, so this condition is met, but the mean is now 30, so this condition is not met. So the Poisson distribution will have a mean of 30. Let's have a look at the two graphs together to see if this approximation is a good one. Here's the binomial distribution, where p is 0.3. And in blue is the Poisson distribution with the mean of 30. And as you can see, the Poisson distribution does not closely follow the binomial distribution. So this approximation would be poor and useless. Okay, next example, we have a binomial distribution where these two conditions are met, and here is our normal approximation. So let's have a look at both of these two graphically, and because the conditions are met, the graphs should follow each other very closely. So here's the binomial distribution. N is 80, P is 0.5. So we need a normal distribution where the mean is 40 and the variance is 20. And as you can see, the normal distribution is a very good fit around the binomial distribution. So we have a very good approximation. Now let's have a look at the Poisson to normal. The Poisson here has a mean of 30, so the normal distribution has a mean of 30. The Poisson variance is 30, the normal variance is 30. Let's have a look at both of these two graphs together. So here is a Poisson distribution with a mean of 30. And now the normal distribution with a mean of 30 and a variance of 30. Yeah, that's quite a good fit. It's not perfect, as you can see. Yeah, we are using approximations here, but it's a good fit. So what would happen if this value of lambda, this condition here, that lambda is more than 15, is not met? So let's use a lambda value of 2. So the mean here would be 2, the variance would be 2. Let's have a look at these two graphically. So this is a Poisson distribution with a mean of 2, and as you can see, it does not have a normal curve. And here's the normal distribution with a mean of 2 and a variance of 2, and it's a poor fit, and the normal distribution goes into the negative region here. Clearly the Poisson distribution cannot have any negative values on this side. So a poor approximation, because this condition was not met. So what we've seen here is the impact of these conditions being met, so where the graphs have very similar shapes, and we've seen examples where these conditions are not met, and the graphs do not have similar shapes and lead to poor approximations which are useless.